So this is what the geometry looks like in the ICEM. So this one is the inlet for cold fluid and the outlet for the cold fluid. Similarly, here is the hot fluid outlet. This one is the hot fluid outlet, and this is the hot fluid inlet. So cold fluid enters here, leaves here. Hot fluid enters here and leaves here. I mean, hot fluid enters here and leaves here. Nothing special about that. A common shell and tube heat exchanger with counterflow. Now, the external walls are have another part, the outer wall. This is the outer wall, and then there is a common wall which is shared by the cold and hot fluids, which is here in green. And then we have an interface where the two small pipes meet the bigger pipes. One is the cold inlet interface, and one is the cold outlet interface. So these are the parts, and of course we have the curves and the points in separate parts of their own. So this is the geometry, and as I explained in the introduction, the blocking philosophy would be like since this geometry has outer features like these small pipes attached to the main pipe, it has these outer features, and it also has the inner features. I mean, there is a small diameter pipe inside the big diameter pipe, so it has outer features as well as the inner features. So that's why uh, uh, when we have such a geometry, our blocking philosophy should be like we should first create the blocks to capture the external topology here, and then when we have captured that, we should then move towards the internal topology, the inner cylinder in this case. So that's what our blocking philosophy would look like. Uh, so let's initialize the block first. So we have initialized the blocks, and then uh, so now we want to make splits to capture the external topology. So we will uh, we will make splits here and here, and then here and here, here and here to capture these two external topologies from this view. Now we move to the top view, and we need to capture the cylinder here. So we will again go for edge, and let's say prescribed point should be this one. So we see here we have the required splits to help us capture the external topology. So we have the required splits here. Now we will delete some blocks just to make things a little sweeter for you. We'll delete the blocks. This block, for example, these three blocks should go because they are not required for the geometry. So should this block. Similarly, the blocks here should go along with this block. So in the topmost row, only the blocks in this column should remain. Similarly, in the bottommost row, the blocks in this column should remain. So let's delete the blocks. Before I delete, let's start index control, and I will use index control to improve my selection, to make my selection easier. So the blocks here have been deleted. Then I go down. So sorry. So I delete these blocks again. I use the polygon option. I middle click. Then I again middle click. Say okay. Then I again use the polygon option. I middle click to once to confirm the polygon. I again middle click to confirm the blocks. Then I say apply. So we have a better shape now. We still have more deletion to do. So this okay. So we have been able to capture the shape, the external shape. Now we begin our association. Now I begin the associations. We will associate the smaller pipes first at the two surfaces, the interface as well as the outlet. So this small pipe as well as the small pipe here will be associated first, and then we'll move to the bigger pipes. Nothing special about that. We could have associated the bigger pipe. Nothing special about that. So then we go to associate edge to curve. For the smaller pipe on this end, So I have associated the pipes, the smaller pipes on two ends. Now I associate the bigger faces. So I finished the associations. Uh, so at this point in this lecture, the outer geometry has been captured by the topology. So if you see here, the outer geometry has been captured by the topology. Uh, we need to capture the inner geometry first. Geometry now. So to capture the cylinder inside this cylinder, as we know, we will have to make an O grid. We have already served, I think, countless examples in module 1 and module 2 where inner cylinder is captured by making an O grid. Before we make that O grid, let's project the vertices. Because it's always good to have the vertices at their correct places as much as possible before you make the O grid. Because once the O grid is made, the number of vertices rises dramatically. So the number of vertices rises dramatically after the O grid is created. So it's better to move the vertices as much as possible before the creation of O grid, and that's what we are going to do. So we are going to project vertices, all visible, say apply. So the vertices have been projected. So after creation of the first O grid, we understand that the first O grid was created to capture the curvature of the small pipes here. So now we need something, another O grid to capture the inner cylinder. So we will create another O grid inside the first O grid to capture the inner cylinder. In order to do that, let's first get the useless blocks out of the way by using the index control. We go to blocking, right click index control, and then so we have selected the blocks necessary for O grid creation only are on the display. So we go for O grid creation now. We select the blocks, we say all visible, and we select faces. Then we say middle click, apply. So we have created the another O grid to take care of the inner circle, and so the now we associate the edges to the inner cylinder. Or maybe not. Before we do that, let's move the inner O grid blocks to another part, the solid part, the hot fluid part, because it's a multi-domain mesh, and so a different fluid will be flowing there. So by index control, now we will move these things to another part. Say create part, hot fluid, clocking, say all visible, say dismiss, save it. And I do my association now. So I have done the association. Project the vertices. So the problem we are facing in projection of the vertices is that uh, these these uh, these vertices here are associated with the closest surface, which is this one. So that's why when I do project vertices, they are projected here. So I need to change that. So I will switch off the wall. I will switch off the wall and then I will project the vertices. So now the projection is the way we want it. Now I begin with applying the node distribution on each of the edges.